The tutorial is about programming scientific instruments in Python, and obviously the first thing is to ask yourself. So my name is Dan of course, actually. Well, I work in the email math group here at ICMAP, and I do quite a lot of programming of my own experiments, and I thought I would share this with you. So the first thing that you might think is, why would you actually need to program instruments in your own lab? And there are several reasons. These are some of the reasons. So first of all, it might be that the instrument you've got doesn't actually have a piece of software, and you want to record things with your computer instead of sort of writing data in your notebook. So it might have no software, and so you need to implement some software. The software might be unavailable or incompatible. You change computers. You had a previous license, a software installation from equipment that was maybe 10, 20 years old, and now you move to a different computer, and now the software is not there anymore. It's not compatible with the new operating system. So all these things are things that can happen in the lab a lot, because instruments last many years. You might have a licensing issue. So you might have a software that has a license that is non-transferable between different computers, and you might want to replicate the same experiment in different labs. So you might have to buy new licenses, and this license might actually not even be available anymore. The software might be inadequate. It might not do what you want. This is quite common in science. A certain instrument might be designed to do a certain experiment, but you're doing something different with the same equipment. So that's another reason. A very common one is the need to control multiple instruments at the same time. So you have, for example, in this slide, I put a laser down at the bottom left corner, a spectrometer, an oscilloscope. You might have power supplies. You might have source measure units. So you might have a more complex experiment going on, and you need to control it all at the same time. And the instruments might have to sort of interact through the computer between each other. So this is another reason why you might need to do that. And then as well, this is actually, I personally find it quite important. It's actually the way that you save your data. So it might be painful to analyze data that comes from different sources, different software. And so if you can acquire the data in a format that is convenient to you and for your analysis, it might save you a lot of time. It's a very common that when you start programming your own equipment, you kind of don't really know where to start from, and this is kind of what this whole seminar is about. So going through sort of the main ways of communicating with a piece of equipment, and you buy an equipment that can be connected to a computer and programmed. These are sort of three big categories of equipment that you're going to come across. The first is a VISA equipment, VISA instrument. It's short, this virtual instrument software architecture. This is sort of most big equipment is going to have this sort of interface. So it's, I would say, the industry standard for benchtop instruments. So for digital multimeters, for source measure units, oscilloscopes, lock-in amplifiers, and a whole range of other instruments. And this is sort of your best bet. In general, it's a very convenient interface, sort of communication protocol to work with, because you only need one driver installation, which is this VISA driver, and it's a general driver it's sort of interchangeable. So you can use this. You can, if you have the VISA protocol installed in your computer, this is the driver that you have to download once and install once. And you can download it from a range of different suppliers. You have all these different VISA variations: National Instruments VISA, the Keysight Input-Output Tech VISA, Rohde & Schwarz VISA. They all pretty much do the same thing, and it's kind of a compatibility layer between your instrument and your computer. So the instrument will interact with this compatibility layer, and then interact with the computer to give you the data that is being transmitted to the instrument. So this is very convenient. It's actually the most common type of instrument that you come across. But another category of instruments that is also very common still is that of serial instruments, completely serial instruments, so that use serial communication to interact with the computer. So this is very common in simple instruments. So for example, power supplies, some basic lasers, shutters that only have to open and close. Simple motion stages as well. So in this case, the serial communication is a text-based communication protocol, just the same as the VISA. So you're sending text messages to your instrument. No driver is required because it's kind of a very old standard. You might need a driver for the serial adapter in case your computer doesn't have a serial port, which is quite common. But this will normally be self-installed when you connect the first time the USB device, sort of USB to serial adapter in your computer. So generally, there's no driver required, and it works on any operating system, just like the Visa. Once you have the Visa driver installed, these two categories of instruments will work on any operating system. And then you have the more complicated, and it's I grouped this in a single category because it doesn't belong to the other two. It's instruments that work with their own software development kits. So these are generally more sophisticated equipment. So particular equipment that needs to transfer a lot of data, because all the two previous categories, they work with text-based interaction. And text-based is okay because we can actually read it. It's human intelligible, but it's very slow. So comparatively, it might have a speed that is sort of in the range of a megabit per second or something like that. But if you need to transfer, say, image data from a camera, you can't do it that slowly because you need possibly many megabytes or potentially gigabytes or gigabytes of data at once, sort of, or in a very short time. So you can't use text-based communication. You need to use something that is more specific. But for it to work, it needs to run with its own drivers. So these are instruments that always have an instrument-specific driver that is also, in general, developed for a specific operating system. So it might be Windows, Linux, Mac, and you have to make sure that the instrument you buy is actually compatible with the computer you're going to use it with. So it's binary communication. There's no text going on here. There's text in the commands, but in the actual interaction between the instrument and the computer, generally this is sort of done through a binary communication that is fast but not intelligible for humans. And so typical examples are cameras that transmit a lot of data, spectrometers, some motion stages, they might have this, some interface adapters that I've come across also work this way. And it's the typical thing when you install something in Windows, and you might have come across this .dll extension. It's typically, this is called in Windows, it's a Windows specific thing. Other operating systems have different ways of working. It's a dynamic link library. So it's kind of a library that tells Windows what commands it can execute with that particular instrument. So we're not going to look at that type of instrument today because it's a whole kind of worms that there's no one specific way to deal with these instruments, but rather we'll be focusing on the Visa instruments and on one Visa instrument and one serial instrument. So one important thing that I want to get out of the way is that the communication protocol is different from the hardware interface. So the communication protocol is this thing that we talked about Visa and serial. And it has, in principle, nothing specific to do with the hardware interface. So a communication protocol can adopt different hardware interfaces. So for example, one particular instrument, and I have here a Keithley source measuring unit that we're going to use today. This one specifically, it's one instrument that can be connected through a GPAB port. This is IEEE 488. It can be connected with a USB connector, with an Ethernet, and there's some even more connectors. So you can decide how you want to program it. And they all use the same Visa communication protocol. So the port doesn't actually assign the type of instrument that you've got. The serial instruments, they do generally connect either with a USB connector or a serial port. There are different standards of serial ports, but the most common is this one with 9 pins that you can see on the bottom of the screen. And then you have the GPAB, which is sort of an older standard, which is still around, and you can still find it in many instruments, which is a parallel port with this very big connector. It's very common. That one will generally use a Visa protocol. So what are we going to do today? We also mounted a very simple experiment. So I'm going to point the camera towards the. See if people can actually see that. Right. So I've got a very simple experiment set up here. Let's see, yeah. So what I got is a power supply, which is this 10 mAh. So I've got this 10-mile programmable power supply, which is this instrument here. And you can see, well, it's now turned on. It's showing some things. It's a programmable power supply, cheap one, and it communicates with the serial interface. And it has a USB connector on the back. And then I've got this source measure unit, which is a source measure unit, which is another pretty standard sort of laboratory piece of equipment. And so with the programmable power supply, we're going to drive an LED, which is here. I can just drop this height a little bit so you can actually see it from Zoom. So, well, you might not be able to see it on Zoom, but anyway, there's an LED here, which is that green LED that's in the presentation. And then we got right in front of the LED, we have a photoresistor, which is this little device here. And that's a resistance that will change the value of its resistance with light. Okay, so the idea is that we use the power supply to generate a light signal. The LED will turn on with different intensities depending on the voltage that we apply. And the photoresistor will pick up the light and change its own resistance. So it's a very, very simple experiment, but it might be similar to something that you might come across in your own lab. Okay, so that's today's experiment. And now let's get right into the practical things that we need. So the software that we are going to use today. So the first thing is the National Instruments Visa communication, sort of the driver. So you can find it at this link here. Unfortunately, since a few, well, I don't know, months ago, now you have to actually create an account. Control click this. So I might just quickly open a browser so you can see the page, but basically now you will have to so you'll need to download this National Instruments Visa. Once you have to here to create an account, so you can download it, but I mean it's free. It's annoying, but that's the way it is these days. So once you download that, you install it. That's one part of the software story. Then you have the Anaconda Python. So Anaconda is just a Python distribution. So you can install Python in a computer in many different ways. This is a very common distribution in science, generally speaking, because it includes a lot of packages that as scientists we use quite often. And this you will find on the Anaconda webpage. Okay, so here you just download it. This is all completely free. You don't need an account to actually download it. Yeah, and then so right. So these are the two things that you need in terms of the software. Once you install the National Instruments Visa, you can already start to interact with your instrument. And we're going to do that in a second. The last thing that I'm going to mention is the Python packages that we need. So Python, once you install it through Anaconda, your computer will sort of understand Python, so to speak. And but we'll need to install a few additional packages that you will need for this particular tutorial and generally to communicate with instruments. So specifically, Conda does not come with pyvisa already pre-installed, so you'll need to install that. Pyvisa, pyserial, and this pyqtgraph, that's another package. So if you want to install a package, if you install Anaconda the usual way, Anaconda actually has a feature which is called Anaconda Navigator. You can open it and it will have a fancy interface to install packages. Thing I found is actually not all packages come into this fancy interface. I don't know for what reason. So I generally don't do that, but rather I would run a command line. So this is the so-called Anaconda Prompt, and it looks like very much like the Windows prompt, command prompt, but it runs basically through Anaconda. So it will actually understand, as it is, it will understand the Python commands and then the Anaconda commands. You can find it. It's here on the taskbar. But once you install Anaconda, it will come up in your search list as the Anaconda prompt. You might need admin permissions to actually do that, so just keep that in mind. Once you install Anaconda, in here you would type the messages that we had a look at here. So, for example, you would type this message in. Now, I actually haven't run this. I haven't run this Anaconda prompt through with admin privileges, so it will complain. But generally, it will list some text, and it will figure out the compatibility with other packages. At some point, it will ask you if you want to install the package or not, and you just press yes, and that's it. So with this, you will basically be ready to program everything. So I will just close this. You see, it's sort of solving the environments. It's doing its own thing. It might take a few minutes for it to do everything it needs to do. But in this case, I'm just going to shut it because that's going to just take some time, and it's all already installed. Okay, so that's it for the slides. There's nothing else. So let's get down to business, really, and talk about what happens when you actually get your instrument. You get it out of the box, you put it on the table, you connect it with the power supply, you connect it with the USB cable. How do you know that you're actually able to interact with it? Okay, so it's generally the first step, and also something that I would personally do before opening Python. Because we installed this National Instruments Visa protocol, actually this NI Visa comes with a utility which is called NI Max, which, since it's already installed, you might as well use it. So when you click the NI Max software, it will come up with this little window, and this window will actually list all the equipment that is connected and available for Windows to talk to. So it will load the details of your computer, and then if you go on the devices and interfaces, you'll see that there's a list of things, and the one that I'm interested in is this Keithley Instruments source meter. Okay, so it's already found it. This is how it should be. So you install the software, you connect the instrument, and there it is. So what do you do with this now? You have to interact with it, and the interaction is text-based. So you have to send messages to the instrument, and you have to read what comes back from the instrument. The utility to do this comfortably. So if you don't mind, I'll sit, because I'll be typing things as we go along. So in this case, what we want to see if the instrument is talking to the computer, or is able to talk to the computer. So what commands are you going to send? Here you have to open the manual of your instrument and see what commands it will actually recognize. So generally you will go here. It's going to be terrible. All right, let's see if can I move this bar? So anyway, whatever. So you go and open your big fat manual of the instrument that you bought. This specific one has nearly 900 pages, so you need to know what you're looking for. I kind of know what I'm looking for because I've programmed this instrument several times, but what you're looking for is the command reference, something that's called a command reference. And this is a list of all the commands that the instrument is able to take. In this particular case, all the Visa instruments actually have a few commands shared and common for all instruments that are compatible with the Visa standard. So I'll just go straight ahead with this little demonstration. So we opened the Visa test panel, and this is a little widget here, and we go on the my connection is unstable. Well, sorry, Zoom people, that's you're going to have to deal with it. But please let me know if there's any connection issues. I'm assuming everything is going well on the Zoom front. Chat. No complaints. Okay, good. So we'll carry on. Right. So the Visa test panel. You have the configuration. Generally, don't touch anything here. It's not necessary. You just go straight to the input-output, And so you see here that we can enter commands, and we can use this interface to write, read, or query. Query is to write and then immediately to read. So it means that we're using a command that we expect a response to. There are many commands which you just send to the instrument to instruct the instrument to do something, and there's nothing that comes back at you because there's no need. And there's this particular syntax for this command, which is standard for all the Visa instruments, and you just need to know that it exists. And it's in the manual, but you need to find it. And it's this star IDN question mark, and which means just we're asking the instrument to identify itself, okay? And this /n, that's a new line character. You might be familiar with this if you do some coding in general, but it's kind of a special character that is sent to instruments to indicate a new line. Anyway, this is kind of how it works. So we can query this, and this is the write operation. So we send this. The return count is 6 bytes. Not really know what that means exactly in this specific context, but the read operation is probably 6 bytes. 1, 2, 3, 4, 5, 6 characters. There you go. So that's the 6 bytes. That's probably what it refers to. And the read operation has returned 52 bytes, and it's all been because it's text-based. This is actually what's coming back from the instrument. Keithley Instruments Incorporated model this one, and this is the serial number, and that's what's come back from the instrument. Okay. So now we know that we are talking to the instrument. So that's already a first step, and you can generally be quite happy when this happens. But if it's an instrument that you never actually touched and interacted with before. So we're done with the national instruments thing. So we're going to do the same thing now in Python, and then in Python we're going to start building up more interactions with the instrument. So more and more commands, and we'll see where we get to. So I'll close the National Instruments Visa. So when you install Python, you need to write some code and you need to execute some code. So this is generally done. There's many ways to do it. The way that I find sort of very convenient and quite common when you install Anaconda is to use the so-called Anaconda Spider, which is this piece of software here, which will come pre-installed in your Anaconda installation. So I'm going to click Spider, so you'll see what it looks like. Okay, so this is what it looks like. It's a very simple interface. It's a very simple interface. You've got actually when you open it the first time, you'll have some more widgets and windows open. I normally just use these two. So this is where you put the code that we want to execute, and this is where we see the result of what we executed. And this is also a command line, so we can write directly text in here and execute one line of code at a time. Yeah. So if you've never done any programming, don't worry too much about it. Just kind of try to follow the flow of things, and then in your own time you can go to the lab and with your computer, your instrument, and try and practice a little bit. So it's not essential that you understand everything, but just sort of the general concept of what we're doing. And please feel free to ask questions. I also say that to the people in the Zoom. I'm assuming I'll get notified to some extent of any questions. So right, so we got a blank piece of code. There's nothing here. This is just comments. I could safely delete this. So we're going to start with the Keithley instrument. Okay, we're going to start programming that. So I'm going to save this. I've created a file on the desktop. Let's see, can I go up one? Yeah. Desktop. So if I go on the tutorial page, and here I've put the code folder. So I'm going to call this Keithley 2612B, which is the name of the model that I'm using. So there it is. That's the file. And now here I can start writing some code. Okay. So we are going to interact with the instrument through a package that is called pyvisa, Python Visa. It's a Visa implementation for Python. So first of all, I need to import the package. So I'm going to import pyvisa. There we go. First, if I want to check if the package is actually available, I can type it in here, import visa. I'm not sure whether it's Visa or pyvisa. I think it's pyvisa. We can have a look at that. I've got it in my notes here. It's pyvisa. And so notes in the back. So import pyvisa, and I enter that. It works. The command didn't return an error, so I've actually imported now pyvisa. So import pyvisa. I'll just shut this console and rerun it. Import pyvisa, and now in pyvisa we're going to use what's called a resource manager. So it's a particular object in pyvisa that it will allow us to do that. So so I'm going to call it RM as in resource manager. So pyvisa dot resource manager. There we go. And so that's what the first command that we're going to use. And in fact, we might just as well type it here. RM equals pyvisa. But we'll need to import pyvisa. We'll just run it from here. That'll be a bit easier. So I can just execute this code, and it's executed. So now I have a variable that's called RM. That's my resource manager, and I can go for RM dot. I think it's called list. Resource, there we go. But there should be a command that's for list resources. That's what I was looking for. So we can list the visa resources. Okay. And this is what's coming back at me. So this is the output. So we have a resource, and it all looks like very strange characters, but actually these are the addresses of the instruments that we have connected. So this is one address, this is the second address, and this is a third address. Two I recognize because one is the Keithley, which is this one here. And you might ask me, how do I know that? Well, from a little bit of experience and also from the NIMAX. So in the NIMAX, we can go to the connected instruments. And here we have the visa resource name. It's kind of like an address. Imagine as if it was like an email address or any kind of address that is used to identify things connected to the computer. So this is the address, and you can see that it's exactly the same there. So that's what we've got. And then the other two are other connected things, which the resource manager has found. But one of the two is, I believe this one is the power supply that is connected, but we're gonna deal with that later. And this, I don't really know. It must be some kind of internal connection of the computer, so I am not quite familiar with that. Yeah.
That's okay. When you see that kind of response, the upper one is a Visa device, and the other two are not.
The other two are definitely not. I know for sure that they're not Visa instruments. It doesn't mean that the Visa resource manager will not find available ports to communicate with. So even with serial instrument, you can to some extent use the well, we'll see that later, but you can actually use the Visa protocol to some extent. It's generally not safe to do that because the instrument is very basic. So there might be some additional communication details that the instrument doesn't know how to deal with, so you might get unexpected results. So if you know that the instrument is a Visa instrument, then use it. The Visa protocol might work with serial instruments to some extent, but I would advise not to do that. But yeah, in principle, it's possible. Do we have a? There's a Q&A. Yeah, thank you, Jose. Yeah, that is definitely, it's a virtual COM port. I think that's correct. We'll see that later. We'll be programming yeah, there we go. Yeah, so we'll be programming later the power supply. So I don't know what's connected to the COM1 port. It might be the keyboard, the mouse, or some other device, internal device for the computer. And this definitely sounds like the COM3, the third virtual COM port, which is the one that I know is connected to the power supply. So thank you, Jose. So we've got the list of resources, and then we want to therefore, so now from the list of resources, we can get this address, okay? So we need this address to open the resource, which is our instrument. So I'm going to copy this address, and here I'm going to go for, I'm going to call it my Keithley, just to put it as a variable name, and I'm going to go for rm.open resource. And here, resource name, I have to put the address, okay? And it's this address, but I need to put this as a Python string. So I'm just gonna put it between these apostrophe, because that means that it's a Python string, and it's a Python string that contains the address of the instrument, okay? So I'm gonna reset this and execute the code again. There we go. So now in principle, I should have my Keithley. So if you in Spider here, so Spider keeps track of the variables that are in the workspace that we've got. So if I type my and then press the tab key, it will actually autocomplete it will give me a suggestion of the variables that have potentially that name. So I go for my Keithley. And now here I can already start to interact with the instrument, and it's very easy because the pyvisa protocol implements the write, read, query commands and many others. So I can go for my myKeithley.query, and you see that it already finds the query command. And as you type, the Spider will pop up some documentation about the commands that you're about to use. So query, and here I'm going to put the same query that we actually used in the earlier in the NI max. So I'm going to query the identity of the instrument. Okay, and if I press that, this is exactly the same text that we got earlier today, just a few minutes ago, yeah, from the NI max. So it's a Keithley instrument. It gives me the model and it gives me the serial number, and this is I think the software version. Okay. So there we go. So we can interact already with Python and with the instrument. So we'll move on with sort of creating all the different commands that we actually want the Keithley to do, right? So we want the Keithley we want to be able to set a measurement range, a current limit. We want to set the voltage. We want to set the output, whether we want to turn the instrument on and off. And so we're going to do that. I mean, we can quickly test a few commands as is. So now to know what the commands should actually look like, we need to go back to the manual. Okay, so we need to know what does the Keithley actually react to. So if we go to the manual, and now I'm sort of somewhat familiar with the Keithley commands. So these are all the different commands that you can send to the Keithley through the Visa interface. And the one that we want, for example, is the, let's have a look. These are the SMUX source level. For example, this will set so the Keithley, for example, how we're going to use the Keithley today as a source measure unit. So we're going to output a voltage and read a current. And this function will basically, it's a measurement of the resistance of the device that we've got. That's how we're going to use it today. So here you need to get a little bit familiar with how this whole thing works. But this Keithley has two channels. I'll skip the technicalities, but basically we want to use the SMU, which is the source measure unit, channel A. So X is the source measure unit channel, and it gives you an example here. So if we want to apply a voltage signal on the channel A, this is the command that we need. So you might not be able to see that on the Zoom or here actually, but anyway, I can do a write command and send this command to the source, or maybe you might see a bit more from the Zoom and actually also from in the room if I turn the output on and off. That's probably a better idea because you're going to see an LED light up. So I go here and look for the source output. So now, right now it's set at 0 volts. So I'm just going to turn the output of the Keithley on and off. So I choose the channel, SMUA, and here I put output. and then I follow the instructions of the manual. So I can do smua.source.output equals source output, and I go here and I can say 0, 1, or 2. 0 is to turn it off, and 1 is to turn it on. And this is another function that we're not going to use. So output equals 1. Close it. This is the text command that I'm sending to the Keithly. And if you have a look at the Keithly front panel, which is going to be here, you will see an LED. Well, it should light up. Yeah, you see the LED lights up. So I'm talking to the instrument, and I can do the same thing and turn it back off again. And there we go. It will return some things. Don't worry about it. This will generally not come back when you actually interact with the instrument. It will not always return a string. I don't quite know what this 24 means. It's probably some kind of residue of communication. I honestly don't know, to be fair. You won't generally get this when you write the code and you execute it as a script. So just ignore this 24. Just ignore it. Right. So here we can now implement all the different functions of the Keithly, and today we're going to concentrate on just a few, the ones that we actually need for the experiment itself. So before doing that, so it's very convenient, particularly if, well, in Python definitely, but generally speaking, to be able to write code that is modular. So you can import instruments that you have programmed in the past. So you don't need to program it every time and import everything and rewrite the whole code every time you want to do a different experiment, but rather write your code as modules. Okay, so that's what we're going to do now. So instead of writing all the code here as it is, we're going to leave this at the bottom, these 2 lines of code. But here we're going to declare what's called a Python class. So you don't need to worry about it. It's just kind of a way of generating a Python entity, okay, in the code. So we can then call it from different bits of code without having to copy paste all the code in the script that we're actually writing in that particular moment. So we're going to create this class. So of course, this will be if you know Python, you might be more familiar with it. If you don't, just don't worry about it. The first time you actually start to do it, you'll come across all these little details, and it won't be that hard to understand, to be really honest. So I'm going to create a Keithly class, Keithly, and I'm going to call it 2612b. There's a lot of little syntax details which are really not important for what we're doing. When we create this Keithly class, every time you create a class in Python, when you first create an instance, what's called an instance, so an object that belongs to that class, there is a function that is generally placed, which is called the init function, and it's a function that is executed every single time the object, an instance of the object, is generated. So also, again, some syntax there. You will see this self keyword popping up quite a lot today, and it's a way to say that this function belongs to the class that we are defining. Again, it's something about the syntax of the language, so really don't worry about it. But you will see it come along several times. So, and then what we need to create an instance of a Keithly object is that we need to specify an address. So imagine that we're calling this class from different these different programs. We have to assign an address so we can actually generate the instance of the instrument. And it's best to therefore use the address as a variable. So I'm going to put here just the address variable. And so here we have to then open the Visa resource, which is the Keithly, with the resource manager. So here I'm going to create, just as we did here, this RM. I'm just going to call it resource manager. Resource. And pyvisa, which is imported up there. And then I'm just going to copy this. Okay. Open resource. but instead of putting the actual address here, I'm just going to put the address variable. Okay. So we have the, oh no, sorry, that's not the, save that for later. Pyvisa, I first need to open the actual resource manager, which is this. Okay, so I need to open the resource manager, and then I can for instruments. So I'm going to have in my Keithley class, I'm going to have an instrument variable, which is to indicate the instrument itself. Okay, so self.instrument is again then resource manager. Resource manager variable dot open resource. Okay, so it's the same exact thing that we've done here at the bottom. And then there's an additional thing that we can add. So you see here how when I queried the identity of the instrument, at the very end, we get this termination character. Okay, so this is the new line character. It's not a problem, but it's something that's going to come up every time we send a command to the Keithley and we receive a response. So there's a little feature in the pyvisa library, so you can specify what the termination character is. So every time you talk to the instrument, the pyvisa will actually remove this character from the output, and this will save you some headaches in handling that little character at the end, which will always be present. So we can put this as the termination character. Character, and in this case we know that for this particular instrument it's the new line character. Okay, so it's this one, and then we should be able to then put this as a read termination. This is a little bit related to the syntax of the pyvisa package. Termination character, it's a little bit cumbersome to read. So read termination is the termination character that we set up here. Okay, so this is all we need to do for the initialization. And now we want to actually add a few functions. So the first function that we can add is the identity function. So we can put the function IDN. We can call it just the same as the command that we're going to send. And so here, when I call this function, what I want the Keithley to do is to send me the address, and then I want to receive back the identity of the instrument. So I will write return, which is the function return, what the function does. Not every function needs to return things, but in this case, I want the function to return something. So when the function executes, it will return. What will return? It will return self.instrument dot query. So we ask for IDN, okay, which is the identity. Right. So let's see if this all works. So it's a very primitive Keithley class. So we have the resource manager. We actually don't need it here anymore. What happens is that the address, the visa address, they generally will stay always the same. So once I find this string, which is the address of the instrument, it will always be the same. So I move to a different computer, I use the instrument in a different lab. In principle, they should always remain the same because it's basically done, it's a composition of the interface, some variables, and then this, which is the serial number of the instrument. So generally speaking, this will always stay the same if you're using the Visa protocol to interact through a USB connector. So now that I know the address, I don't need to look for it again. I already specified this. So my Keithley, and instead of open resource, what I do here is that I define this as an instance of the Keithley class. Okay, so I call the Keithley class. I pass the address. The address goes in here, and then is used to open the resource manager. and assign the address to the open resource command that we had before, okay? So I'm going to execute this, and I'm not getting any errors, and let's see if this works. So I go for my Keithley, and now in principle, my Keithley should have the one function that I implemented, which is IDN, okay? So I just execute IDN, and in principle, I should get back what I wanted, okay? So I've got the identity string, and you see that it's missing that termination character that we had earlier. So this is just a little thing that helps you get this character out of the way. So here we go. We're now sort of basically ready to implement all the functions we need for the Keithley. And we're going to use a few different ones. Specifically, we're going to use the ones for to set the limit, the range, the output, where we want to turn it on and off, the measurement of the current. And we also we're going to put a reset function, which is quite useful because we're going to run and rerun the same thing many times. So first I'm going to implement a reset function. And this is also a Keithley command. In this case, there's nothing I need to get back from the Keithley. This is so every time we actually do something with the Keithley in our demonstration, every time I re-execute the code, this will make sure that the Keithley will reinitialize itself in the same condition that it was when I first executed. So in this case, I go for self.write. And here, again, I need to check the commands of the Keithley. So you scroll down and there is a, let's see, it should be a reset command, and there is reset. Okay, so I just need to send this piece of text for the Keithley to reset itself. Okay, so self.write reset, and now also I'm going to put this reset command in the initialization of the Keithley, so that every time I create a Keithley instance, it will execute automatically the reset command. So I'll go for self.reset. There we go. The reset, in this case, it often makes sense to call the command the same as call the function the same as the command, but of course the commands will get longer and more complicated. So the name of the function should be something that represents what the function does rather than the specific syntax of the command. So that's the reset, and now I'm going to populate this with a few more commands. Specifically, I want to set the measurement range. So I'm going to call the function set measure range, for example. Again, I'll put this self attribute here. Now, set measure range, I need to pass in the function what range I want. Okay, so I will need to specify a variable for that. So that's going to be a range value. And here I go for self.instrument again, .write. And here I need to find the command to do that. So I'm going to quickly go and have a look, but I've got it here in my notes. So that's going to go for smua, smux dot source dot range. There we go. So this is the command that we want. It has this kind of syntax. And so this is the sort of syntax, and that's exactly what we're going to copy and paste in the command here. So again, I have to send it as a string because remember this is all text-based. So smux, and today we're only going to use channel A. Of course, in the manual, it puts an X because X can be A or B, so it puts X. So it's kind of more general. And then we set the range, and we have to set the range of the type of measurement that we want to do. In this case, Y can be the voltage or the current. So I'm going to put, today we're going to measure current, so I'm only going to implement this as a range for the current measurement. And here, range value, now of course, this is a string that we're sending to the instrument, but my variable is going to be in Python. So I need to have a way to actually put this piece of information inside the string that I'm sending to the instrument. So this is a Python way, just simply Python syntax. So I need to put these brackets and then I can put format, and here I put what I actually want to send to the instrument. And That's going to be the range value. Okay. So if I call this function, I pass the function a value of range. In this, it will usually, it's in amps generally, amperes. So I can pass 1 amp, 0.1, 100 milliamps, 1 microamp, whatever. So I pass this to the function, and then we send to the Keathley the request to set the range to that particular value. Okay. And we're going to do the same here for a few more functions. So we're going to call the set source limit. This is the limit of the, maybe before the limit, well, we can implement the limit. We're just going to implement a few functions, which are the ones that we really need. Set source limit. Again, here we can, well, I'm going to implement just the voltage limit. Okay, so limit value again, and here we go, self.instrument dot write, and here we look for the same as before. Now I already got it here in my notes, so we're not going to go through the PDF again. SMUA dot source dot limit, and in this case it's a limit of the voltage, because we're going to output a voltage, equals same as before, dot format limit value. That's a second function, and we're going to implement one more, well, a couple more really. I'm going to set the the source range. These are also specific Keathley commands. So it will look the same as the one above, but with a different command. So I'm just going to copy paste this. And in this case, this is not going to be the this is, sorry, this I got it wrong. So this is the measurement range. So I believe it's self dot measure range. There it is. So sorry about that. I just got spelled that one wrong. So we have the measure command here. The measurement range. Okay, so that's the measurement range for the current, the source range for the voltage. So I've got that there. What else? There's the actual voltage that we want to put as an output. So set source voltage. And we can call that just V, maybe to make it simple. Self.instrument.write SMUA.source.level. This is called level, level V. And here we put again the same thing as before. Dot format V. Right. In principle, we can now debug this. I'm going to add maybe just one more function, which is the measurement function. And I think that'll be it then. Measure I. So in this case, I'm not passing anything to I'm not passing any values, any variables, because I'm just asking the instrument to give me a reading. So yeah.
The capital letter in L is okay.
Where?
Level is have capital letters.
This one.
And the second one is okay.
Yeah. It's not capital.
Is it the same?
Yeah, I think in actually
in the PDF is so.
Yeah, so okay, this is again an instrument specific thing. There are instruments which might be bothered about whether you're using capital or not. I think specifically the Keithley isn't. The Keithley doesn't care. Although this is something that I should check again. I generally go straight for small sort of non-capital letters. But yeah, this is definitely something to check. There might be instruments which get annoyed at you changing. I mean, they want this command in a specific letter format. So yeah, this is, but yeah, this in this case, the capital that the manual uses here is simply you see it actually the example itself is in non-capital. So yeah, it's a good point though. Thanks for asking. So here we have the set source voltage. So we in this case we just write. So we no, sorry, the measurement. So self.instrument dot query. So in this case we're asking something from the instrument. So we're querying. So I'm going to send a write command, and then we're going to read something back. In this case, again, it comes back a little bit to the syntax of the instrument, and in this case, you have self SMU measure command. So now, if you just do the measure command, the Keithley will actually store it in its own memory. So we have to use a print function to actually get it out directly. So this is a little bit sort of a little trick that we need to use for this specific instrument. Other instruments may work in a different way. So we actually need to implement this command through a print request. So we ask to print smua.measure.I, and this is what it looks like. Yeah. And then we have to close the bracket for the print function. So we're sending the Keithley the command to print the measurement. Okay, so this is actually going to get us the measurement out. Okay, so that's pretty much all we need, really. There's nothing else.
How do you know when you have all commands can be write and query, or do you have to know it beforehand?
You should know beforehand. What's going to happen is that if you query and the instrument has nothing to tell you, it will just give you a timeout error. Generally, you can test this quickly. So I can go for my Keithley dot, for example, query, and I can send the same command that we have here. Which is not a command that is supposed to give me any. So I'm just going to query dot format, and here I'm just going to put the source voltage. I'm going to put 1 volt. Okay, just for the sake of the example. Let's see. Yeah, dot format. Okay, sorry. Okay, let me just check if this is actually, yeah. Anyway, so I can query. Now, well, you might not be able to see it from here, but let's see if the command works. So the command, it will write a command, and that should already execute what it's supposed to do. But I suspect it's going to give us a timeout error. So I'm just going to run it. Oh, sorry. Yeah, because my Keithley, that's the instrument, but inside the class, I have the instrument object. Which is what is supposed to be the querying. Okay, so I just skipped that. So you see now here it's set to 1 volt. I can, well, but you see it's giving me a timeout error. No panic, it's a timeout error. I asked something from the instrument didn't reply, and at some point it times out. It just means that Python is not gonna by default make me wait forever for something to come back if nothing is coming back. Okay, it was supposed to come back ages ago with in sort of computer time. So nothing happens. So you can use the query. You should be careful because this happens in the middle of your experiment. It might break your experiment. I mean, you might need to handle the exception in a way that doesn't break your experiment. But yeah, thank you for the question. So we carry on. So I'm going to shut this down and rerun it, and we can just test. Right, brilliant. So that's probably, let's see. Yeah, okay, because again, like here I didn't put the instrument because to use the interaction with the Keithley within the Keithley class, the key, this thing is just a class, okay? So inside the class, I have the instrument variable, which is the actual thing that is doing the communication. So I'm just gonna rerun this. Okay, so nothing's happened, no errors in principle, but now I can go for myKeyfly dot reset, for example, and this is a command that exists and it's fine. I can go for output. Yeah, we haven't implemented actually the output method. So we're going to do that next. Let's just do it right away. So set output self.instrument dot write again, and we go for SMU A dot, I believe it's just look dot source dot output equals, and then we have to put actually what we want the output to be. Just going to call it output, and here we have to go again dot format output. Okay, so this output should be, well, I can put a little comment here, because output should not be a strange number, it should be 0 or 1, okay, either off or on. So I can put 1 to say on and 0 for off. This is just a reminder, this is just a piece of documentation. There we go, that's it. So I'm just going to shut this and rerun it. And so I can go back to the previous commands. myKeyfly dot, for example, measure current. Okay, and now this is a query command. It should give me back a reading from the Keyfly. Of course, now it's not outputting anything, so it's probably just going to measure a little bit of noise. Brilliant. I didn't put the return. So return. Okay, so let's rerun it. So I'm going to rerun the same command, and now this is what's coming back. So whatever range setting it's got, this is a reading. I need to know. I need to go back to the manual and know what does this mean. This means minus 2 point whatever, 10 to the minus 8 amps. Okay, this is the reading. I need to know that the unit is in amps, which is stated in the manual. In this particular case, you see that this is actually, it has these 2 apostrophes here, which means that this is actually a string. So I need to be careful with this. And in fact, before I get it wrong later, I'm going to put this in a float conversion, so that actually, when I run this command, instead of getting a string back, Python will automatically convert it into a floating point number. It's basically a floating precision number. Okay, so that's it. I can test a couple more commands. Let's see, myKeyfly dot, for example, set source limit. Well, I'm going to put set source range. And here again, setting the range of the Keyfly, I can actually, it will take pretty much any value, but it makes sense to give it values that have meaning for the instrument. So if you go in the Keyfly manual, up here, probably in the general description, let's see, front panel, rear panel, introduction, maybe capabilities and features. Here we'll probably give you like a range of, well, it tells you what values actually make sense. Just this is a big mess of a bit of a small screen to actually see everything. But there is a range. We will need this later actually, but I'll try and see where this is. Our measurements. Anyway, I don't want to waste too much time on this. Have a quick look at the basic operation range. There we go. This is what I wanted. So here it actually gives me what ranges make sense for the instrument. Okay, so you can see that it goes in multiples of 10. starting. So our instrument is this one. So it goes from 100 nanoamps. So it makes sense to implement ranges which take these specific values, okay? So I can set a range of, for example, 0.1 amps. Remember that in the code, we always have to put things in amps. So set the range, and I'm going to pass. Now, I haven't put any documentation, so it's not telling me what I'm supposed to give it, but set source range to, for example, 0.1. This is the voltage range, I believe. So I don't know if, let's see. So actually, I think the voltage range actually goes in multiples of 2. Yeah, there you go, the voltage ranges. So the minimum is 0.2 and the maximum is 200. So it makes sense to actually go for set range, for example, 2. Well, you can't see it here. I don't know if you can see it actually change range here. I'm going to try and do the same thing as before. Try to keep an eye on the video here, and you should see some digits shift in the instrument. Yeah, actually, it's a bit subtle, but it just sort of changes the range of the instrument. So this is the way for me to know that the command is working correctly. Okay, so it's a good idea before proceeding to test at least once each of these commands. I'm fairly confident that they work, but we might as well. So we have the set measure range. At least that they don't give an error. This particular case, I need to switch actually on the instrument what I want to visualize. So I want to read amps. So set measure range, and here I can put 0.001. That will be 1 milliamp. And this actually does something on the display, so I know that it's correct. And we can quickly test set source limit. This is not actually this is not going to be visually, you can't really see it because you can set the source limit to be, it's a limit, set source limit. Actually, this should be a current limit because we want to limit the amount of current that we want to deliver to the photoresistor. So I'm not going to test this because right now it's I just change it. So we have tested this, set source, set output. Actually, that is the one that we are very interested in. Set output, and we can set it to 1 to turn it on. And you can see the LED that turns on there, and set output to 0, and now it turns off. Okay, so I'm fairly happy that it works. Okay, so it does what I want. These are the basic functions that we're going to need today, so I'm not going to add any more. And we're going to go straight to the programming of a graphical interface for this instrument. Okay, I see we're tight on time, so anyway, if we don't manage to cover everything I wanted today, I might do a follow-up seminar at some point in the future, probably next week or something like that. Anyway, we'll see how we go. Right, so now I've got all the text commands ready in my code. Now, if you have a very simple experiment that you want to do, and it's always the same, you might simply use here, you might write a piece of code to just run whatever things you want. You can implement a function that maybe runs a sweep or sets a certain number of values, waits a certain amount of time, takes some measurements. So you can already imagine using it just a simple text interface that you already, as it is, you can do pretty much whatever you want. But of course, it's very useful when you are doing experiments that you are able to actually see what you're doing, see some data coming up, and also use the instruments or instruct the instrument to do things with buttons. Okay, with buttons and with values that you can change in real time without going through a text interface, which is quite painful actually. So the next thing we're going to do is to implement this user interface. Now in Python, there's different ways to do it. So today I'm going to show you the one that I use and I find quite convenient. And it's through a user interface package called PT. So I'm just going to shut this. And so I'm going to show you how to build a simple graphical interface where you will be able to change all these settings and then connect this this interface through Python, so you can interact, you can write code for the interface itself. Okay, so I'm going to save this, and temporarily we're going to move to a slightly different software, which you will find already installed in Anaconda, but you'll have to go through. You won't find it here by typing, and the program is called Qt Designer. And it's a kind of a drag and drop interface to create interfaces, to create graphical interfaces. So you won't find it here if you search, but you have it already in all Anaconda installations. And to find it, you have to specifically go into this hidden folder, which is normally a hidden folder. So you need to enable it through the settings of your in the options here. You have to tick the options to display hidden files, folders, and drives. So it will display this folder, Anaconda 3. I think it's library, bin, and then here you have a little icon that's called Designer. Okay, so it's already the program is there, but you need to know where it is. And they created here a shortcut, so it's convenient to create a shortcut the first time you go and use it, and this shortcut actually points to the Designer executable file. So I'm going to shut this, and I'm going to open the Designer interface. So here in the screen, the resolution is a little bit small, so it's a bit annoying. But anyway, what you want to create is a so-called widget. Okay, I mean, I'll just close this and show you the actual interface. So this looks a bit terrible because the resolution of the screen and the projector is not very high. But I can now go here and I can create a new, well, this pops up the same window. This Qt is used in a range of things. Okay, a lot of software that you probably use is already written in Qt. This is in and of itself is not related to Python. There's a Python package which is called pyqt, which allows you to talk to Qt interfaces using Python. So you can find this actually also for applications, graphical applications which are not Python related. So here I'm going to create a widget, which is just a blank piece of screen space, really. This is kind of like a window. I can give this window a name, and I'm going to do that here. So here you have, I mean, all these Qt interfaces. So well, I'm not going to save the file. Go away, please. Okay. So I'm going to save this as let's go to the desktop. How can I do this? I'll probably go to documents and then up. And I might put this into quick access. There we go. It's going to make my life easier. So I go to the tutorial code, and here you can see that I'm saving this as a designer UI file, which is a .ui. It's a text file. It's a text file which is written in one type of. It's an XML file, so it's kind of written in its own language, but it's a text file that has basically a text description. It's a little bit like a web page. It's a little bit like an HTML file. So it's kind of like a web page text, which then is read by another piece of software, which makes sense for it to visualize something graphically. So in this case, I'm going to call this the Keithley choose 612B. Now, this is a matter of taste completely. I personally like to give it the exact same name of the class that I defined for the instrument, but then with the UI extension, which is going to be applied automatically here. So I save this, you see that's Keithley choose 612B.ui. And this is the title of the window, which by default is called form. And I'm going to change that here. These are all the attributes, because this will be then saved as a piece of text. So all these different attributes have a certain meaning in the graphical context. But the one that I'm interested in is the window title. Okay, so I'm going to put this title as Keithley choose 612B. Okay. I generally like in the in the names of the files and things to put as a whole piece of text. But because this is just visual, I'm putting actually a space here. I don't mind. But generally, I would avoid in programming things to put spaces in your file names, because sometimes then it's a problem in the string conversions to actually well, not going to go into that. Okay, so here on the left, you have a drag and drop interface where you have all sorts of different typical graphical interfaces. You have the push buttons, the radio buttons, the check boxes. You have a whole bunch of things, really. The ones that we are interested in are sort of text labels, spin boxes, which are, well, it's the typical, I'm going to put a couple here because we're going to need them. It's the typical box where you have arrows to sort of move, to change the values. Then you have the combo box, which we're also going to use, which is the drop-down menu, and that's what it's called. You have the line edit, which we're also going to use. So I'm just going to drop in these all over the place here, and then we're going to sort it out, yeah? So maybe we can sort it out right now. So the way that the Qt works is through so-called layouts, okay? So what you want in a typical interface is that if you resize the window, you move the window around, things still kind of stay in place, okay? So, and the way for them to stay in place is to put these little widget. Everything here is called a widget, basically. The whole thing is a widget. Every little item of here is called a widget. So this widget word is going to come up a lot, but it can refer to different things of the interface. So all these little widgets will be contained inside of layouts, and these layouts are sort of, imagine as a sort of a stretchy boxes, okay? So that when you resize the interface, it will actually resize with some sense. So here I can put layouts already, but the window itself, I can assign a layout to the window itself. So there are different layouts that you can try. So here I'm gonna, you can see that I can lay it out horizontally, vertically, in a grid. There's a couple other options to grayed out. Actually, for what we're doing, the grid is quite convenient. But I wanted to show you both. So right now I'm going to use the layout vertically. So all these icons now have stretched to occupy the whole horizontal space, and they're laid out vertically, okay? So you can see it's sort of like a stack. But now all these things are hierarchical, so I can put the horizontal layout inside the vertical layout. It sounds conceptually complicated, but it's really, really straightforward. So I can take a horizontal layout and I can drop it. This is sort of the graphical aspect of Qt Designer is okay, but it's not great. So sometimes you might struggle to actually place what you want where you want it, and in that case, you might have to use this object tree, which you can see here. That's the tree of all the things that I put in my interface. So that's, you can sort of drag and drop these objects inside the tree itself. Anyway, I'll let you play with it once you get started. So here, what we want is, for example, we want to specify first the, what should we specify? The source range, for example, okay? So the source range is going to be a drop-down menu, because not all source range values make sense. So it makes sense to choose 2 volts, 200 millivolts, or 20 volts, or whatever. So I'm going to take this drop-down menu, which is right now empty. I'm going to place it inside the horizontal layout, okay? So I place it here. And this is a horizontal layout, so I can start things horizontally, and this will now make sense. In and of its own, this doesn't come with any information, so it's useful to put a text label to tell me what this is. So I'm dragging and dropping, so I'm going to drop it here on the left of this, okay? And here I'm going to write source range. And I'm going to put it in volts, so the user knows. And here this is now the drop-down menu, and I can double-click and set all the different options that are going to be available in this drop-down menu. So I can put 200 millivolts. Now, actually, here I have to be a little bit careful. I can't put 200 millivolts because then I'm going to use the actual value that I put in here in my program later on. And because the Heatley will take everything in volts, this should be in volts as well, unless I want to do a conversion later on, which I don't want to do. So I want to keep it all very simple. So 0.2, and I add another one, 2, 20, and 200, which I'm not going to implement because that I will need to connect special things inside the in the key clippings to actually enable it, so I don't want to get any errors. So I'm just going to give these 3 options. Okay, so this is now in the drop-down menu, and here I can set. Any questions? Here I can set the or the current index, which is the default one when the window opens the first time. So I'm going to set this to index number 1 because the index is start from 0, 0, 1, 2 in this case. So I could set it, of course, index 3. It allows me to set it, but of course it doesn't exist. So it allows me to do things that don't make a lot of sense. So you do need to be a little bit careful with what you're doing. But in this case, I'm going to set the current index as 1, and this is going to be the first index that we're going to use. So that's that. Now we're going to do the same exact thing with the horizontal layouts for all the other settings. I'm going to put a horizontal layout here, and I'm going to put a label, and this is going to be the, let me see, the source limit, and the source limit is in source limit current, so that's going to be in amps. And here I should set, so the source limit in principle is not a drop-down menu because I can set an arbitrary limit, but I need to be careful now also with the possible values that this can take, because the interface, if you don't program the interface correctly, then the interface is not going to allow you to do what you actually want to do. So what I'm saying is here in the settings of this double spin box, it's called the spin box because this is what the name of this type of object, and it's called a double spin box because the numbers are not integers, and that's why it's called a double. Double is in sort of a programming sense. It's a floating point number. So we've got the decimals, so I have to decide how many decimals I want. In this case, I'm going to put 4, just because we're not going to go to very low currents, even though the interface, even though the key flip can actually do that. I'm going to put a maximum here. This is also a way so you can control what you're doing in the actual experiment. So if you know that your instrument has a limit of 1 amp, this is you can use the interface to limit yourself from doing something stupid and setting a too high voltage, too high a current for the kind of experiment that you're doing. So this is actually a useful thing to use. So I'm going to put this maximum to say 1 amp because I know that I don't want to exceed 1 amp, and actually the range is such. And the minimum, well, I'm going to leave to 0, and I'm going to put this single step, so how much I'm changing. So when I click one of these arrows, how much is the number going to change? And I'm going to set this to 0.01, just as a sort of increments of 10 millivolts. And the default value I'm going to leave at 0. Actually, that doesn't make a lot of sense, does it? So I'm going to leave it at, well, the same as the single step. Okay, so 0.01. This is just a default, so that's kind of how it's going to look. Okay, let's finish this interface and then we'll have a quick break. And so I'm going to go drag and drop another horizontal layout, another label, and I'm going to call this label, let's see what we've got, the measurement range. Measure range, and that's also in, well, that's also current, and that's going to be in amps. And the measurement range is has a certain set of values, so it's not an arbitrary one. So I'm going to use what's called the combo box, and drag and drop it here. And the range that we're going to use, I'm just going to add a few here. So we've got 1 amp, 0.1 amp, 0.01. And then finally 0.001. But I'm going to use today probably 0.1 amp range. So here again, I'm going to go into the settings, and the current index I'm going to set as 0.01, or actually maybe 0.1. This is going to be my range for today. Right, so we've got the source range, source limit, measure range, and then we have the source voltage, which is the voltage that I will actually want to output in the instrument. So horizontal layout once more, and this is something I actually need to set sort of arbitrarily. So put another label here. Source voltage, and here I'm going to give it the possibility. Let's see, go for a minimum of 0, maximum of 20, because that's kind of the maximum range that I'm going to use. Single step, I'm going to put 0.1 decimals. I'm going to give it 3 decimals for a particular reason, and the default value of 0, so I can go on and increment it at 100 millivolts at a time. Okay, and then finally we have the measurement. Okay, so that's the measurement, the measured current. So I'm going to drop another horizontal layout here at the bottom. This is so the measurement. We're going to implement it as a button, so that when I press the button, I read the value and I print the value in a text box. And this text box is going to be this, which is it's a line edit. I'm just going to delete it and drag and drop it again. So it's a line edit, and on the left of the line edit, I'm going to put a button. It's called a push button. And here I'm going to call it measure current. I could put the unit as well, so people know. And here, this is the line edit. In this case, I don't really need to set anything specific, because I'm actually going to put the text in here from the Python program. Right, so I'm going to save this, and I think we can have the break now. And then after the break, we're going to connect this interface that we made with the Python program, and we'll see how to do that. And then, yeah, we'll take it from there. Let's see how that goes. So let's see if there's any questions before, just before going to the break. Oh, Q&A, yeah, let's shoot. I don't know, is that the same as before?
Mm-hmm.
Open?
I have a question.
Yes.
Yeah, if you can the spider code.
Yes.
If you connect the kill instrument not through USB but through another port or whatever.
Yeah.
It's exactly the same code, and we only change the line 44.
That's right. Yeah, that's right. So we exactly this address looks like this for now, the USB connection. Yeah, if you connect it with the GPIB, all you need to do is change this address. That's it. Everything is the same. You buy a new Keithley, this address is going to change. In your code that you run, you just put a different address, and that's it. Yeah, that's exactly right. The GPIB, well, it's a lot shorter. It's usually like instrument something GPIB and the port number. It's got 27 ports, so it can go from 1 to 27 or something like that. Yeah. Any other questions? Yes.
In the designer,
Yeah.
it's done, so can you put them as a like function of other variables, or you need to do that instead of like?
You mean that as you click something, something else changes within the? What do you mean function?
Yeah, because for example, intensity limit.
Yeah.
It's more like the product. I mean, it's power limit, not itself voltage. Intensity limit. So
This one.
It should be like the product of intensity and voltage.
Well, this is actually something you can, specifically in the Keithley, you can set independently. So in the Keithley, you can set the limit is kind of, in the Keithley, well, the way it works is that you tell it what voltage to output, and you can tell it to have a current limit. So generally what happens is you apply a voltage to whatever circuit you've got.
Yeah. But I mean, the maximum limit that the intensity that you can get, it's related to the maximum power that it can store.
It's related to the, yes, of course.
So that limit will be different if you have the range of the voltage.
Yes, definitely. I mean, the Keithley will allow you to do that. It will just give you an error. So you can actually I can set the range to be lower if I want, because I can do it manually. I can set the range to be lower than the limit. And then if I try to ask the Keithley to give me an output value, which is higher than the range that is currently set, it's not going to let me. It's going to give me an error the instrument itself is going to give me an error. So yeah, of course it would make sense. I would say there's no way to connect within the interface, as far as I know, there's no way to connect within the interface one value to the other. Okay, so I can't say that this value from the interface itself, I can't say that this should be the product of this and that.
Yeah.
Okay, this is something you would do in Python. In Python, afterwards, once you create the interface, you can do pretty much whatever you want. What I'm doing here in the designer is I'm generating the interface this way using the Qt designer, but you can generate the same interface simply writing code or using pyqt, which we're going to do later. So you can add widgets from code. You can set all these parameters from the code, and Qt designer is just a simple visual way to drag and drop buttons and interface elements. So yeah, but you can definitely do whatever you want under the hood. Okay. Anyone else? Any more questions? Okay, so we're going to have a quick break. I would say 11:45. We get back. Right. So we have this interface now. I could resize this a little bit. This is going to change just the sort of default way that the window appears on the when I actually generate it. Okay, so we saved this as a file. Now I'm not going to close this because I'm going to need it a little bit more later on. But this is now saved. Desktop. This is saved as a file right here. So that's it's just in the same folder. And now we have to actually use the file. So call it within Python to do something with it. Okay, so to do that, we're going to need the so-called pyqt package. And so this is what I'm going to do now. Okay, so I'm just going to import a few things, which I'm going to use later. So it will, I'll import it now, so but it will make sense a little bit later. So I'm going to import OS, which is a package to manage things related to the operating system. And in my particular case, I'm just going to use it later to get to the directory of the file that I'm trying to open, the user interface file. And then here I'm going to import a few packages from pyqt5, import Qt widgets. So I'm just going to import a bunch of things. You need to know what to import. This is what you need to import. I'll tell you that now. So once I import this, I'm going to create a new class for the Keithley interface. Okay, so this is the class for the Keithley instrument. Now I'm going to create a class for the Keithley user interface. So I'm going to go here, and I'm going to write class. Let me just have a quick look. And I'm going to call it Keithley, same as before, choose612b _ EY. Okay. And now, in this particular case, the Keithley was sort of an instrument of its own. There's nothing else that it needs to, as we say in programming, inherit from other classes. But here in these brackets in Python, what you have to put is if there is any other class that you inherit from. So inheritance in object-oriented programming is just a way to say that a certain class belongs to a certain other class, which is more general. And because this is an interface, I want this class to belong to the class of all Qt interfaces, specifically widgets. So it's a little bit of a technicality, but so you just follow along. We're not going to put right here. So here I'm going to put Qt widgets dot Qt QWidget. QWidget is what I want to. QWidget, there it is. And it's auto-completing with some brackets. Okay, so Qt widgets.QWidgets, and that's what I imported up here. Okay, so this is the class, and now same as before, I need to put in place the initialization of the class, and here I'm going to therefore have this def init function. And this init function now, this is the it's going to have a self, just as we had before. And now this is a Keithley interface class, and I'm going to have to give to this Keithley interface class the instrument itself. Okay, so I'm going to put this this as an argument, as a variable here in the init class, the Keithley itself. So when I call when I generate this class, I'm going to pass the Keithley object, which in my case here is this my Keithley. Okay, it's going to be all a bit more clear in a minute once you actually generate the interface. So here another bit of Python trickery. You just sort of, I'm just going to put the command in. If you do the same, just put the same. I'm not going to explain what it is right now. Basically, this is necessary when we are generating interfaces through these Qt widgets. We need to put this this particular command that I'm going to put in place because we're inheriting from another class. In this particular case, I need to explicitly execute the initialization of the other class as well. And this is done through this super.init function. If you're developing your own things, just put this line in whenever you're using Qt widgets, and things will work. It will give you an error if you don't. So I'm not going to delve into the details of what this actually is. So I'm just going to put it in place. And now I have to create within this. So I'm going to pass when I call this this class to generate an instance of the an object of the Keithley user interface class. I'm going to pass the Keithley instrument, but this therefore is momentarily stored as a local variable within this function. So I have to assign it to the class itself. So I'm going to go self.keithley equals Keithley. This means that the instrument that I pass as an object is being assigned to the class itself, and I will be able to refer to it with self.keithley in the rest of the code of this particular class. And so the other thing that I need to do now is to tell the class where to look for the user interface file. Okay, and so I have to add the file path. And this again, you need to know what the syntax is for this particular UI file path. And here is where I'm going to use the OS package. So I'm going to go for os.path.join. So you just need to kind of follow. This is just syntax for Python. What I'm telling Python to do basically is to give me the name of the directory that I'm currently working in. Okay, where I'm currently executing this this file. Keithley choose 612 .ui. Okay. So I'm giving the path of the user interface file, which is what we created with the Qt designer, using this package and join without the G. Join the path of the directory of where I'm currently executing, and this is kind of how I generally use it. I put the user interface file in the same directory of the instrument that I'm programming. Okay, so so it looks like that. So that's the user interface file path, and now we're going to add through this piece of syntax the user interface load UI, and here we're going to put the UI path and then self. This again is take it as it is. We can't go into the details right now of why it looks like this. I personally also, when I program a new piece of kit, I would just copy paste these few lines, and I also personally don't go into the details of how UIC works and why these are exactly the arguments that we're using. Okay, We've now created the preliminary class. So this will, in principle, connect the user interface file that we created. And now here outside, so when I execute a piece of code, Python will sort of, let's say, pre-compile the classes that I defined, but then the actual code that gets executed is this thing that's here at the bottom here. So if I remove this line, the code will run and will not do anything, actually will not create anything. So in this case, I'm going to put here all the few lines of code that are actually necessary to start the so-called Qt application, which is kind of the engine of the user interface. Again, it will be a few lines of code which are a little bit technical, but that's kind of what you need to get this all up and running. So I'm going to call generate a variable. It's called the user interface app, and this is a Qt widgets .q application. So I'm kind of telling the again, I'm going to put things that you just should not worry about. And you just do the same, copy paste it when you're doing your own application. So that's the user interface app. Then I have to generate the user interface, a class of the Keithley UI, and that's that, which is the one that I created just here. And now I need to pass to the class the Keithley itself, and that's what I put here, yeah, the Keithley. So what I'm passing is the instance, so the object of the Keithley that I was using before. So that would be my Keithley, yeah. Now I have to actually show the interface. This is very trivial. I have sort of UI.show. The user interface is this, and then finally, this is another step, which is a little bit technical in the sense that it's related to how Qt works, is that the UI app that I created in the beginning, I have to actually execute it. And that's how it's done. Okay, so these few lines are a little bit technical. Just keep them there when you're doing your own thing, and you can go and look what they actually do and why they're necessary. So in principle, now as I run this, a window should pop up. Okay, so I'm gonna run it. Let's see, unless there's any errors. Yes, there's an error. Let's see. It's probably not very useful. Let's see. That's what happens when you do things in real time. 261.2b. I think it's missing it's not finding the file not found error clearly, so there must be an issue with the name of the file. I think that's I mean the proper way to do it will probably be to copy paste the name of the file from here. So you just make sure that you're not making any errors. So I'm just gonna rerun it. There we go. This little thing popped up. This icon, well, it looks like the Jupyter icon if you're using Python for other things. This icon might look a little bit different, but in general, it should give you the interface that we just programmed earlier on. Now, of course, this interface now, it's here. I can change things, but nothing happens because nothing is connected to anything. Python is PyQt is showing me this. It's allowing me to change things, but I haven't programmed any interaction with the actual instruments. Okay, so I can press these buttons. Here I can write stuff, but this doesn't really mean anything. So what we need to do now is connect all these so-called widgets to functions inside the Python script. Okay. So I'm gonna shut that down, and then so we have the class of the widgets. So we know that it works, so it opens clearly. And now we're gonna add the functionalities one at a time. Now what this does, this import function, this load UI command, right, is that it takes the widgets of my user interface file and import these widgets as objects inside of this Python class, okay? What does this mean? It actually means that there is an object inside my user interface, which is called right now, and it takes the name of the object name here, which is called combo box. So to access that object, so this combo box inside the code, I would go for self.combobox, do something, whatever. For this reason, it actually makes sense to rename all these widgets with names that make sense. So in this case, I'm going to call this, I generally give it, I personally, it's a matter of personal style, I like to put rather some slightly longer names that are descriptive, because when you program some more complicated things, you can get a big mess of variables and objects. So what I usually do is to put something that sort of resembles the label that I put and the name of the variable that it relates to, so that when I come back to the code after a few months, it still makes sense, and I can go in and change it relatively quickly. So here I'm going to call it source range combo box, and I'm going to do the same thing here. And I'm going to leave the, I could remove this combo box piece of text, but it's something that I personally find quite useful to leave, so you know in the code that you're referring to a user interface object, okay? So I'm going to leave that there, and I'm going to leave the double spin box as well. That's why a big screen is actually quite convenient when you're programming in this sort of way, because you can afford to have longer variable names, and it doesn't completely saturate your screen, and you can have multiple things at once visualized. So source limit, I'm going to call that source limit double spin box, measure range combo box. And we have the source voltage double spin box, and here we have a line edit, because that's a different one. Measured, I'm going to put it measured I line edit, and this is the button as well. Measure I push button. These are all the labels. These don't really have a function, really. I could interact with these as well if I really wanted in Python, but because these are just labels, they're sort of things for the user to see what they're doing. They have a name as well, but I'm not interested in this name, so I'm just going to leave it default as it is, label 1, 2, 3, whatever. Okay, so we've got these functions. So now let's start, for example, with the source range. Okay, so I'm going to take this and copy the name of this. And now I'm going to create a function here, which takes the value from that box and puts it into the Keathley. Okay, so I'm going to put define. That didn't copy properly. No. What's this? Well, I'll just copy. I don't know why the Control-C is not working. Maybe it's assigned to some different. So I'm going to define. This works well. So now I'm going to remove this because I'm going to need that a little bit later. I'm just going to paste it here to have it to use in a minute. And here you could use, there's no problem really, because this is a separate class, okay? There's no problem really in using the same names as in the original Keathley instrument class. I would say I often actually do that deliberately, but in this case, just for the sake of clarity, I'm going to give this a different name. So all these functions that we had earlier, I'm going to re-implement basically with to say that they are coming from the user interface. So set source range from UI, and this also has to belong to the class. I'm going to put this self attribute, and here I'm going to go for self Keathley dot set source range. Okay, and here I have to put the value that's in the box. How do I access this value? Well, we need to know the way to access it. Well, the proper way, because you don't know in principle how this is done, is that you go in the Qt documentation, which is always very enjoyable. So you go to pyqt or just Qt. I'm going to go for pyqt combo box get value. Okay, Generally, there's a PyQt documentation for the combo box itself. This is the sort of the official page, for Qt applications. And here you have all the functions that are related to the combo box. So this is already pretty much implemented. So you just have to find the function that you need. And the function that I need is somewhere here. The one that I want is probably one of these, get something. Let's see, because I've got it in my notes. I'll just give it a very quick look. Current text. This is the one that I want. Okay. Current text. Yeah, Qt. Well, you see that this comes up as pyside2. Well, let's say the Qt is. There are two variants mainly that deal with this. This class of interfaces. One is called pyside, the other one is called pyqt. There's just sort of two different libraries that have pretty much the same commands. And what you find as pyside, just don't worry about it. It's this command. I can go deliberately to the pyqt library page, and I will probably find the same command. Anyway, it's a little detail, but. So current text, this is the function I need to use. So I need to use the object of the box, the combo box, and I need to use the function current text. Okay, so that's what I'm going to do here. So I'm just going to copy paste. Let's see if I can actually. Let's see. Yeah, that worked. So set source range, and now this is the Keithley command that we implemented earlier. Set source range. I need to pass a value, okay? What value am I going to pass? I'm going to pass self dot the name of the box, source range combo box. So that's this, pretty much. So I'm going to move that there. Dot current text, okay? In principle, this function, this command, takes the combo box and returns the current text that is in the combo box, okay? And then this text is passed to the set source range function of the Keithley to set the value in the instrument, okay? This is sort of a more compact way to do it. I could put it in a separate variable and then call the function, but that's pretty much what you want, okay?
You have to transform to float.
In this case, the Keithley is quite happy with what I'm going to give it. Yes, it will be potentially safe to do that. You might want to transform it. Actually, the Keithley will always be happy with text. The Visa protocol, in this case, takes care of this. With a serial instrument, you'll have to be very careful. In this case, the Visa instrument, if I pass a float, it will convert it into text in an appropriate way, so the Keithley will actually take the value. So I think in this case, as long as what I'm passing makes sense, so in this case, it has to make sense because the combo box itself, I think, as it's not specifically a number format, it will be a string. So it will append. What you have to think about is what is the Keithley going to see, right? What's it going to see? It's going to see the result of this. So current text is going to return a number as a string format. So it's just a piece of string. That string, when I call the set source range function, is going to be placed, set source range. So this range value through this piece of syntax is going to be dropped in, is going to replace these two brackets. So what the Keithley is going to see is SMUA.source range v equals whatever I'm going to put here. So it has to be a string, basically. And this dot format command in Python takes care of formatting a number into a string. So that's the Keithley will always see a string coming its way. Okay, so now I've created a function to transfer the value from the box to the Keithley, but I need to now connect this function to something within the interface that happens. I need to actually make this function happen, okay? It can be a button, it can be a different type of function, and I'm going to implement that right now. So in the initialization of the class, here is where I need to put all the connections to the interface, okay? So I'm going to write it and then we're going to comment, okay? So I'm going to go for self dot, and now I have to put the name again of this object, which is because I loaded the UI, this object now exists. Now the only drawback of this process is that Spider, so the interface, doesn't know what's in the other file, so I can't autocomplete. I can't use the tab keyboard button to actually autocomplete, because the class here, I mean the Python script here doesn't know that source range combo box is something that exists somewhere else. So that's why I need to copy paste it deliberately. I can't autocomplete as I was doing before. So self dot source range combo box, and now here I need to decide on an event that is going to trigger the function below here. This is called in the Qt language, these are called signals and slots. We're not going to go into that syntax right now, but anyway, I need to tell when is this function supposed to happen, when is the key supposed to be updated with the value from the box, okay? And this is something I have to decide myself as a user when I design the user interface. In this particular case, the combo box has a certain number of functions, which we can have a look again here, and this will be in the signals. Okay, within the signals you have all the possible events which are pre-programmed within the Qt library that can happen and which can trigger an effect. Okay, which can trigger the execution of a function. In this particular case, what I'm interested in is probably either current index change or better current text change. Okay, so if I go in the combo box and I select something, that selection, the fact that I clicked it, will trigger this clicked event. So current text change, I'm gonna copy this and put it in the code. Dot current text change dot connect, and this is the keyword that I need to use. Dot connect to what? The function that updates the keylet setting. Okay, so self dot source range set source range from UI. Okay, and this is a specific syntax thing. In this particular case, you connect it and you don't put the brackets as if you were executing. You just connect it to the name of the function. Okay. So what this does is that anytime I click the combo box and I select a new value, this is going to automatically execute this function here. Okay.
What is the difference between index change and text change?
It doesn't. So what can happen is that I can change these things programmatically. Okay. In principle, whenever you change the index, the text is also changed. But it might be that for some reason I have two options which have exactly the same text. So in this case, the text wouldn't have changed because the text is the same for two options. So it really depends on what you're implementing. In my case, it's completely equivalent. It might be other cases where, for some reason, all these things that I'm doing now, sort of programming the interface and connecting to the interface, I could do the reverse and generate the interface from the program. Okay, so that's it allows you to do that. Now I'm going to implement maybe another one, maybe the one with the button that is a little bit more obvious because a button is something that I generally have to click. Here I'm going to implement the output button, which actually, this reminds me, I haven't actually implemented it in the interface. So I'm going to put a push button, probably I'm going to place it right here, and I'm going to call it output. So this is the button that turns the key on and off. Okay, so here again, I'm going to put the output push button. Right, so I'm going to say that. Always remember to say these things. Is it recording? Yeah. I think I clicked record.
Yeah.
Yeah. Okay. You get me very nervous. So, right. So here we're going to call put another function, set output. Again, I'm going to label it from UI, just to be completely clear. And here, self.keithley. Well, actually, here, what's going to happen is here I'm not passing a value, I'm just telling the Keithley to turn on. I mean, conceptually, I've implemented this as a button, okay? So I don't have to read any value, but implementing this as a button, actually what makes sense to do is to have either a button to turn it on and a button to turn it off, or what you can do, and this is a specific advantage of buttons, of these push buttons, is that you can set it as checkable. This means that you're going to see in the interface when I actually do it, is that when I click the button, it will sort of remain pressed visually, and then I can press it again so it comes back to the original state. You're going to see it will be completely obvious once I execute for the first time. So I'm going to set it as checkable. And then what I want to do is when I execute the function, I want to see if the button is in the on state, is checked, or the button is in the off state. So again, here I have to go to the documentation. So we go, I'm just going to open a different tab, pyqt push button, push button. Okay. So here we go, what we're interested in, let's see. Right, well, we ended up into a bit of a rabbit hole of this whole Qt business in the sense that the push button is sort of a very general object. So, well, I'm just going to put it right from my notes, so so you know which commands to use right away. So just bear with me 1 second. So what we want to do is we want to check the state of the button. Okay, we click the button. We want to see if the button is in the on state or in the off state. And depending on whether if it's in the on state, we want to turn it off. If it's in the off state, we want to turn it on. That's what kind of visually we want to happen. So we have to put an if-else statement. So if self dot, now we have to put the name of the button, which is output push button. If self.output push button dot, and here is the keyword is checked. Okay, so when this executes, the Python will look at the button and will see, is it checked or is it not checked? If it's checked, it's going to return true, and therefore the condition is going to execute. If not, we're going to go into the else case. So if the button is checked, and go to self.keithley dot set output, and we turn it off. Okay, and if it's not checked, so I'm going to put an else statement, self.keithley dot set output, set output, and we're going to turn it on. Okay, and now same as before, we're going to put a connect function here, a connect statement, self.output push button, there it is, dot clicked. This is the keyword that you need to know. If the button is clicked, I want to connect to the set output function, self.set output from UI. Okay, so now with the buttons it's a bit more obvious because I click the button and it's obvious that clicked is the action that triggers the execution of this function. Okay, so I'm going to save this. It's important that you make sure that you saved all the UI files. So I'm going to execute this, and in principle my interface pops up same as before. And now let's see if it works. Okay, let's keep an eye on the output LED. So if I click this, I probably implemented it the wrong way around. So the output is now supposed to be off. So yeah, we're gonna. You can see that I can turn it on and off, but what I've done is I program it wrong. So I'm gonna close this down, because now, of course, once I click the button has changed its state. Okay, so if the button is in the on state, I need to turn the Keithley on. So what I implemented is kind of like a toggle turn it on. If it's on, turn it off. But this is kind of the actual way to do it. So I'm gonna rerun it. Okay, so I turn the output on, and you see now the button changes into sort of like a pressed state, and then I depress it, and it turns off. Okay, there it is. So it works. The other thing that I can try is the set source range from UI. Let's see. It's supposed to. I don't know whether you'll be able to actually see the people closer here can actually see if something happens. So let's see source range. Yeah, you can see actually something happening here as I click. There's a little comma that moves. It's very subtle, but anyway, it works. Okay, so I'm happy with that. One thing to notice is once you execute the UI, this will generally block the text interface. Okay, so you will have to close because the Qt application is running. This is what the for the command line here. Basically, there's a program running. Okay, so it's running something, so it can't take your commands because it's already executing something else. So that's why here I can't. If I wanted here, I can't really type anything because it won't let me. I need to close this first. Okay, so that's pretty much it. All we need to do now is connect the rest of the UI elements. So the source limit, the measure range, the voltage. So now here we can pretty much. So for the combo box, we have another combo box, which is this one, the measurement range. And so I can copy paste this below. Just need to be careful to change the names correctly. So set measure, I think it was the measure range, yeah, set measure range from UI. Set measure range, I can use that. Set measure range, self dot measure range combo box. And if you just double check that this is actually what it's called, measure range combo box, that's it. And again, with each of these, I need to connect it. And I'm going to connect it with the same sort of feature as before. Except that now, it's a bit dodgy, this Control-C, I'm not sure why. It's probably something with a keyboard. I'm just going to copy paste it that way. So measure range. Measure range combo box, send up connect. I need to connect it with this function. Yeah, set measure range from UI. Okay, so that's one more button. You just need to double check with these copy paste operations that you don't mess it up, connecting something you weren't supposed to connect. And then we have the source limit. Okay, so this we need to actually implement separately because it's not a combo box, so I can't reuse the same function. But let's see. So I'm going to put a new function here. Sorry, be fine. I'm just going to use this set source limit from UI. Self dot. Now here actually it might, just to make it a little bit more readable, well, not it's necessary, let's see. So to set the source limit from UI, I have to go for self.keithley dot set source limit. There we go. And the value should be the self dot source limit spin box. And now from the spin box, I need to actually get the current value. This is something that I need to again look up into the documentation. pyqt spin box or double spin box get value. generally, if you look up something like this, it will pop up with the there is value. It's as simple as that. So I use this dot value function to get the value inside the spin box, and so that's all I need to do. Dot value. So I take this value and I pass it to the set source limit function of the Keithley, and then again I need to connect it. Self dot set source limit double spin box. But I can just copy paste it from here. Dot what? When is this actually supposed to trigger something? Again, we go back to the documentation, and generally you want to trigger a change when you change the value in the spin box. So we go into the signals, value change. There we go. So when this happens, we want the function to execute. Oh God. Copy this. Value change dot connect. So when the value of the spin box is changed, we connect it to set source limit from UI. Okay, so that's that done, and we're missing one more function. We're going to put that here, which is another spin box. So I'm going to put that here. And this other spin box is the source voltage. Yeah. So I'm going to copy this. Let's see, set source voltage, set source voltage from UI, and set source voltage. I'm just gonna set source voltage. Set source voltage from UI, double spin box dot value, and again we need to connect it. It's a double spin box. Paste source. Double spin box dot value change dot connect set source voltage from UI. Okay, so this in principle should do all we want, and then we finally have the measure button. And so for this, I can already predict that we're going to put a function here, self dot measure I push button dot clicked again dot connect, and we're going to put this measure I from UI. There we go, done. And now we need to implement this this function, which we're going to implement just down here. Measure I from UI, self. Now, what's this function got to do? It's got to measure, it's going to ask the Keithley for a value, and then we have to put that value in that other box that we have in the interface, which is this one. Okay, so first of all, we're going to measure the value first. So we're going to call the measured value. It's a local variable that we're going to create, self.Keithley dot measure, right? And then we're going to put self dot the box that we've got here. Now this box, because we're only using it to print a value, we don't need to connect it to anything. This is not supposed to trigger anything. I mean, touching this box is just a display box. In fact, what we can do here in in the option is to enable the read-only checkbox. So this actually, the user will not be able to type anything in this box because anyway it would be overwritten, but since it's a function it's not needed, better remove it. So measure I from UI. So self dot measure I. What is this spin box called? Line edit, measured I line edit. Okay. Self dot measure I line edit. I'm just going to type it. Self dot measure I dot line edit dot. And here I need to again look up the documentation and see how do I put a piece of text in the text box. So I go back to the documentation and I look it up. Line edit, pyqt set text. Q line edit. I go here and then I go have a look. And I already know that what we're looking for is set text. Okay, because the first time you do it, this might take you a little bit of time, but this holds the lines text, so we can use the set text function. Set text, and here now it is important to actually convert this into a string because we have implemented the Keithley to return a float, if you remember. So here we return a float. So in this case, the Qt is working its own, is doing its own business, and it's expecting text. So if I give it a number, it's a variable type that it doesn't recognize. So we need to convert well, I can do it here or I can do it wherever. So I'm just gonna, str is just a string conversion. It's just the Python syntax. So I'm just gonna copy this and paste it. Copy and paste that right here, the measure value. Okay. And finally, well, this is actually already connected. We already connected this, the button, the click button with the measured value from the interface. Okay, so I'm going to save that and just make sure that this is saved as well. And now we're going to execute it and let's see if it all works or not. All right. So I'm going to keep an eye on the Keithley here. I'm not sure what you're going to be able to see. The source limit, I don't think we're going to be able to visually see anything in the instrument changing. But the measure range, in principle, should trigger some change in the. Let's see if I am. Because every time I reinitialize the code, it will. So now I'm displaying the measurement range there. So if I change it, so yeah, it's doing its thing. And I'm not sure if you can see. If you look at the Keithley screen, you might see actually.
Can you make it bigger?
This.
Yeah.
Yeah, sure. Brilliant. There we go. So measure range. You see, this is in amps now. And now as I change it to different ranges, it will drop to. I mean, I guess it's mirrored the whole. Oh, it's a big mess. Well, anyway. Clearly, amp mils is not what you. It's milliamps anyway. Stuff is changing. It's just the whole thing is mirrored. I can probably change that somewhere, but I'm not sure I'm bothered. So I'll just leave it as it is. So that is just sort of changing things, and then we've got the source voltage. So that should appear here in the bottom. That's channel A. So you see that changing. In different voltages, the source range I can set to maybe 20 volts. That does the little change there. So I can set the source voltage to maybe 1 volt, for example, and then I can click output, and that's the output button. That also works. And I can measure. It doesn't do anything. Let's see. Clearly. right, I've probably forgotten. I line edit. There's probably a typo somewhere. I'm just going to shut it so we can. Let's see, measured value. So it's complained that it couldn't find the measure I line edit.
Measure.
Ah, thank you very much. Thank you. Measured. There we go. Let's see. We'll rerun it again. Also, actually, something that I might do right now, since we're there's nothing special about these functions. Even though I connected them to buttons, I can still use them separately. Okay. In fact, it's a good idea that when you create an interface, that you initialize the instruments to have the values that come up in the interface. Okay. Because if you remember, when I generate the Keithley object, it resets. So it will reset to some standard settings, which are factory settings. So it's a good idea actually to put in here to basically execute all these functions one by one, so that when I run it, the Keithley will already have the settings which are in the user interface. And that's why you can use the user interface itself. So the numbers that you put here, yes, you can change them, but it makes sense to put something useful as a default value, because it saves you from then changing everything in the settings. So that's why that's quite useful. So I would actually, what I would do is to execute each one of these functions, because I might sort of shut down the experiment. The Keithley is left in a certain state, and then I reinitialize the same experiment, and I want the Keithley to go back to the settings, because maybe there's a specific setting that is important. And if I don't reinitialize it every time I rerun the user interface, it will be left at this previous setting, because the Keithley might not change it, or it might reset to the factory settings. So it's actually quite useful to execute all these functions. Now, there are more elegant ways to do this without copy and pasting so much, but there's Qt allows, it's quite flexible really. So there's a I could re-execute. Basically, I could take with a program, I could write some code to take all the widgets that are inside the user interface and take them in a programmatic way and sort of execute each one of them separately. But we're not going to get into that today. So all I need to do here is all the set functions, and these will all execute from I'm executing the from UI function. So even though I'm not pressing anything, there's nothing. The connection just tells the program to connect these functions to these buttons. But as I said, you can use these functions as normal functions for everything. Okay, so this way now the Keithley is going to be exactly have these settings every time I execute it. Okay.
Question. When you do the set output from UI, shouldn't you set it to off?
Actually, no, because what it's doing here in the code, it's looking at within the function. So when I call the function, it's looking at the state of the button. Okay, so in my interface, it really depends on the interface. It's taking the value, what it should be from the interface.
Yeah. So, but when it's off, it will turn on.
When it's so when I run it, the interface will pop up, and as it is on its own, the button is always off unless
If it's off, it will turn on.
it will turn off. So it will. I didn't press the button. Okay.
So you have to press it.
You have to press the button for it to. This I'm just executing as it is right now. It will connect all the buttons. It will get to this point. The program will look at this instruction. It will execute this function, and the function will look. What's the state of the button now? Is it checked or not? As it is when I run it the first time, it's always unchecked. It's always off. So it's not checked. So it will set the output to 0. That's it. It's all that happens. What I could do, if I wanted, for some reason, I could do in here in the program, I could actually go to source voltage, or where is it? The output push button. I could click the button from the code without actually me going there with the mouse. Okay, so all this is also possible, and this triggers it. You can do everything from code as well. that's pretty much always the code is more powerful than the user interface. It can do things on its own. Okay, so let's see if this works now. So I turn on the output. So let's see if that works. Okay, that's the output, and I turn it off and measure. Now it's measuring some stuff. Probably if I turn on the output and measure again, well, it will give me just different values. Okay, so this is just the noise, and you can kind of see how it's already sort of somewhat useful if you are doing experiments on your own now, because you have it all in your computer. You could copy paste this value and do your measurements, but obviously you want to do something more than that. Right. So that's that. Pretty much we've made an interface for our instrument, and that's kind of about 20% of what I wanted to do today, but we're going to carry on another time as well. So let's see what was the actual next thing. Yeah, I might, because we've got another 15 minutes or so maybe it's worth just sort of wrapping up the whole thing with setting up the serial instrument, okay? And then we'll do the actual experiment in another seminar, because it's getting a little bit long. Right, so we'll leave this as is. So we've saved it. We're happy with the fact that it works. And now what we're going to do is pretty much the same thing, but for the serial instrument, okay? Which is the power supply that we've got there. So we'll just create a new file and get started. So now this is a serial instrument. As I said, they're generally more basic than the Visa. You see the manual for this Keithley has about 900 pages or something like that. You can see. Oh God, I'm gonna dock it down there. So you can see the Keithley has this very long manual. It has loads of functions because it's in principle quite complicated. It's text-based, but it's a complicated instrument. It can do many different things. The manual for the Tenma has 8 pages, and this includes all the connections. So this is one of these sort of cheap power supplies. It's probably about 100 euros for this one. So this is also my recommendation. Sort of you can buy the same power supply that doesn't have it's not programmable, and you're going to save about 10, 15 euros, maybe 20. It's really not worth it. Just get a programmable one. So once you want to do something else with it, it really makes a very big difference. So my suggestion is always, if you buy new equipment, always look for something that is programmable, because you never know when you might need to do something with it. So here, apart from all the sort of descriptions, you're going to get at some point to remote control. Okay, this is what the section that you're interested in. Now, the serial communication is kind of more. It lets you get into the hardware details of how the communication actually works. So with Visa, you generally don't fiddle with communication settings, right? You open the instrument is already in principle operating in the optimal way. With serial communication, it's less. Well, there's a few more sort of low-level things that going on with the computer, but still, you'll see that with the pyserial, the serial library for Python, actually it's very simple. In fact, now let's have a look at a few settings. So these are typical settings that a serial instrument is going to give you. So if you buy an instrument that's communicating through serial, it will generally have a short description of some settings that you're supposed to use when communicating with this instrument using a computer. One of the things is the baud rate. This is the frequency, is sort of the number of bits per second that you are exchanging with the instrument. So this means that it will be able to send 9,600 bits per second. This is a very standard number for applications where speed doesn't really matter. It can go to very large numbers, so around 1 million or so, or something like that. But generally speaking, you shouldn't really rely on the data transfer rate for things related to your experiment. But 9,600 is, these numbers also generally can't be any arbitrary number. The hardware of your instrument will usually dictate how fast it can communicate. in this case, like for example, if you're communicating with an Arduino, which has a serial port, you can set the baud rate to be 9,600, 115,200. There's a whole range of different values that you can choose. Generally, you shouldn't be choosing arbitrary numbers. There's a set of values that you can pick and use. But anyway, this particular case, the manual, all it's telling me is to use 9,600. Maybe it's compatible with other values, maybe not. So I'm just going to stick with 9,600. You have the parity bit, which is sort of very low level details, data bit. These are all things that you can generally set. In my experience so far, I never had the real need to set these things separately, okay? Only the baud rate is something I've set, but it might be that with some really old equipment or very specific equipment, you might need to play with these values a little bit. So here we have the DC power supply, the PC, the connection. So the connection, a typical one is a serial interface. Back in the day, computers used to have a serial interface, which could be one of these 9-pin typical ones, or 25-pin or other pinouts. These days, generally, the instruments will have a USB connection. So the USB connection, you see it as a USB interface, but inside the instrument, there's usually a USB to serial adapter. And that's why these instruments actually, in this particular case, when I set it up on this specific computer, when I first connected with the USB cable, the power supply and turned it on, it automatically downloaded the driver for its own USB to serial adapter, because the USB to serial adapter in this case is inside the instrument. So I don't see it. I don't need to connect it separately. But if you have a different piece of equipment that has a serial port, and it only has a serial port that looks like this, then you have to use an adapter, unless you have a serial port in your computer, which if it's a relatively modern computer, you're not going to have. So you're going to have to buy a USB to serial adapter, which really it's USB to serial adapter. It really looks like this. That's all there is, and there's a chip usually on either one of the two sides. Which will convert the serial commands into something that is USB compatible. What was I? Right. So I was actually looking at the manual here, the Tema manual. So in this case, it automatically downloaded. In another computer I used in the lab, actually didn't automatically download. And when you connect it, it's an instrument and the computer doesn't really know what to do with it. And you need to give it a driver. And in this particular case, I actually, let's see. Well, it's a driver that I downloaded from the product page of this particular instrument. I think it's, well, I don't know if I put it, probably haven't put it in here, but if you look for I think I got it off far now. 72. What's it called? 72. 2705. 275. Something like that. Right, so here there's generally somewhere we'll have software. There is. It's a zip file, and inside there's a driver file, and you will have to use this driver. You have to install this driver, or at least go through the device manager of Windows. That's a typical thing that you plug it in. Generally, you'll notice when you plug it in, an object will appear. If it's a serial instrument, it will appear usually in the ports section of this device manager, but it will come up as unidentified device or something like that. And then you right click and you update the driver. And if you've downloaded, you can try to search automatically, which is what happened with this computer. But in the other computer, I had to browse for drivers, and here you have to pick the folder where you downloaded the file. And once you do that, it knows how to communicate it with it, and that's it, all done. And in principle, it should work. So if I go to the let's see, to the manual, here it gives me the syntax of the control commands, and then it gives me the command details. The list of commands for this instrument is literally number 1 to number 12. Okay, so it's got 12 commands that I can give it. You remember the list that the Keatley had, it was a whole pages and pages of commands. In this case, it's very simple, setting the current, the output current, the voltage. These are separate commands to set the voltage and to read the voltage. So it's a bidirectional communication, but as we're going to use it today, we'll all be setting things. So we set the power supply to output a certain voltage, and we turn it on and we turn it off. That's pretty much all we're going to do. So how do you actually do it? One thing that you can see in this particular instrument is that this is not a standard, so it just so happens that this particular instrument, serial instrument, has an identity command which has exactly the same syntax as the one before, okay? So that's what we're going to try and do. We're going to try and see if we can communicate with the device and if the device replies. Again, you can use the NI max. It's designed to be used with Visa, but coming back to the question that came up earlier, whether you can use NI Visa to actually communicate with serial devices, you can see that you're actually able to do that. Now, I know that the device is this one, and the serial ports, at least in Windows, will come up as COM. COM1, COM2, COM3, COM whatever. These ports, I'm not quite sure what it depends on. Sometimes they get assigned to different numbers in different computers. So it doesn't mean that this power supply will always have COM3. That is in contrast to the Visa interface address, which will in principle be always the same. So I can go here. You can see that this actually allows me to set all the parameters that we had earlier in the manual. So this is where all these settings would go. Baud rate, parity bit. You see that all that comes up here. And sometimes you might have more settings than you need, which probably means that it doesn't really matter. So I can open the Visa test panel. I can go into the input-output section, and I can send it a command like this. And we can see I can do a query and hope that it works. I kind of know that it should work, and there you go. So we send the query command, and what it returned is this. Okay, Tenma, whatever. This is the model and the serial number. Typical thing that these instruments return. So we're already able to communicate with the instrument. We know that it's possible. We just need to now get Python to do it. So to do that, I'm going to shut this down. I'm going to create a new file for the Tenma. So it's 7.2. What's it called? 2705. Okay, so that's the tenma.py. And here now I need to import the library. So I'm going to import serial. And I know that that's what the library is called. And now I'm going to create to do it sort of quickly, I can again go for my Tenma equals, let's see, I'll just have a quick look. Serial. Again, now this is syntax of the serial package, the pyserial package, serial.serial. This is, and you see now here, actually Python, same as NIMAX, it gives me the option to add all these settings, but it has many defaults, and it just so happens that generally the defaults are the ones that you want. Not always the same, but one thing that you do have to specify is the port, because the port is never a default. So the port is, as we've seen before, COM3. And now I can add the baud rate, the byte size, and all these settings I can add here as a comma. So I can set, for example, explicitly the baud rate to 9,600, although in principle there's no need. If I want to change it to a different number, then yes, I have to set it explicitly. In this case, because it's a default, I could just leave it as it is. And that's it. Really, that's all we need right now to try and see if we can interact. So I'm going to run it. So now I have a myTenma object here. my10ma. Now, compared to Visa, there's no query function because serial instruments, it's not part of the protocol. You write and you read. That's all you do. So my10ma dot write. And here I am going to put. Now I'm going to put something, and you see how it will probably return an error, but we'll have a look now. So IDN question mark, and again this is a function that we take from the manual. It's here, IDN. So I send the IDN string, and let's see what happens. Okay, I'm getting an error. Why am I getting an error? Because IDN, as it is, it's a Python string. And the pyserial, as I said, it's a more basic type of interface. So I'm sending stuff, I'm sending a string, but this string is not supported. I'm supposed to send sort of bits. But in Python, it's quite simple to do this because all you need to do in Python is put a B in front of the string to say that this is supposed to be represented as a set of bits. Okay, so B, and now it returns something, which again, as before, just ignore it. So I've written the query, but it's not a query in and of its own because I'm not reading anything, so I had to read it deliberately. So I go to my10ma again, and I go to read. I think it's called read all. There it is. Read all, which is kind of going to empty the reading buffer, so I can read everything that is that the instrument has sent. And I go read all, and there is. We got the same reply that we got earlier with the NI max. And you see that again, it's preceded by this B attribute. So this is to say that what we have received is actually it's not a Python string. It's a string of bytes. Okay, of digital bytes. Yeah, basically. Right. So let's see. We've got a couple more minutes. So we're probably just gonna. Yes.
Have you communicated with the kidney before using the serial as we are doing now? So we can do this, or if we do this, we have to connect with serial instead of USB, or we can do it.
You can't communicate with the Keithley with the serial in a serial. I would say no. So if I try to connect the Keithley with the serial library, I don't think it's going to work. I never tried, to be honest, but the Keithley will. Well, I don't actually know. It might be something to try. I don't see why you would want to do that because it's an inferior sort of type of communication. But maybe it would work. I mean, I imagine that the communication still is text based. So at the end of the day, it might be that it works. I can imagine that the data is sent to the Keithley as a set of bits.
So if we connect the Keithley not with USB but with a serial port,
you can't do that.
The pyvisa.
Well, you can't actually do that. The Keithley doesn't have a serial port.
But there are Keithleys.
Oh yeah. Well then yeah, of course. Yeah, absolutely.
But then, like, we communicate with pyvisa or with serial?
You have to check. I would say I never use the serial port to communicate with Visa, but Visa includes the serial hardware interface as a possible interface you might want to use. So yeah, in principle, I would try to use the Visa protocol. I would say probably it should work. I mean, clearly you see that in the NI max, it detected the instrument as a serial instrument, and so the icon I think is kind of a hint of the type of instrument that you've got. But let's see, license interfaces. I mean, you can see that this is. I mean, it tells you what kind of port you've got connected. So I would assume that yeah, you would connect it with a serial port, and it should use the Visa libraries. You can quickly check it, but just try it. Just give it a port, give it an address. I think as this address, I'm not sure what it would look like with a serial connection, probably com something. So yeah, go ahead with it. I would say try it with Visa. It will save you some headaches in the byte conversion and string conversion. Yeah. Okay, so I think I'm gonna leave it here. The next, just a comment on the next thing that I wanted to do. Basically, I was not going to reprogram the whole power supply. Basically, the idea is to do the same thing that we've done here with the Keithley, just with the Tenma, because we're only using just sort of a write command to set a voltage and set whether the output is on or off. That's pretty much what we would be doing, and set a current limit. That's the additional thing. So this thing would be basically a shortened version of what we've done with the Keithley. And also at the same time do a little widget, sort of an interface for the Tenma as well. And so what we're going to do in the next session is we're going to actually see how this connects to the experiment itself. And the experiment will be about setting some voltages on the power supply and reading the voltages on the Keithley, and then making a little plot. And in addition, what I was going to show you is what's called threading. So it's a way to run an experiment without a predefined termination sequence, in a way that instead of doing a particular measurement sequence that starts and then ends, we're going to use the interface itself to say that the experiment should start. So we start acquiring, and then we stop acquiring with another button, which terminates the execution. So it's kind of like a more interactive way of controlling your experiment. So, but then of course that requires a few user interface details, which well, they're a little bit more involved. So I think I'm gonna stop it here. If you've got more questions, now is the time. Otherwise, yeah, we'll.
Like a general question, what is for you the main advantage to use object-oriented programming? Because for me, as I see it, the only thing is that it allows you to create a user interface. But the thing you did with the Keithley, I mean, you can also write it in 10 lines of code.
You definitely can.
And then control it or implement or limit the text.
Yeah, you can definitely do that. I mean, it's an option. I would say the advantage is that you can recycle the same code that you've done in other scripts. So let's imagine I connect another Keithley or another two Keithleys or another oscilloscopes. First of all, it makes it a little bit more intuitive, sort of, when you're using it, because I can, you know, in 2 months' time, I'm not going to remember how I implemented all the basic functions of the Keithley, right? But I will remember that I can go for Keithley dot set output, and I sort of, it's a way of detaching yourself from the low-level code that you send to the instruments. It's a way to make things modular. So I can quickly show you what I've got in my own repository. So actually, you can go and access this. Let's see if there we go. So this is the repository I use in the lab, where I implemented a bunch of instruments. So for example, you can go and find this. This is publicly available, so anytime you want, you can actually see how I implemented things for myself. So in my case, the Keithley code is actually quite a bit longer, because it has well, all the functions that we've seen, but then it has a bunch of other things which are a little bit more involved, sort of to load scripts and things. And I would say it's a way of detaching yourself from the low-level code, which you're not going to look at in a constant sort of repeatedly. But whether you can or not execute everything as a procedural thing, you absolutely can. It really depends on your application. If it's enough for you and sufficient, I would say go for it. The object-oriented programming, of course, it generally starts to make sense when you have quite a lot of code and you want to sort of make use of it in different scripts by calling objects as modules. Okay. So I'd say that is the advantage. So here in my case, I've got sort of many little functions which re-implementing them every time to rerun them all would be quite slow in my software development.
Also, it's possible to not define them as object, but just to define the function in a separate script.
You could do, yeah. Yeah, you could do. I would say if you find yourself comfortable with that, I would say yes. I personally like the modularity of it, and a lot of things in Python work as objects. So I would say it would be difficult. Well, I'm thinking whether you would be able to. You need to use the objects, for example, the interface. Yes, you need to inherit from a Qt widget. So if you can't inherit because you're not using an object-oriented programming, you can't really do the interface because you're gonna end up missing a lot of the functionalities. So I would say for that reason, you do need the object-oriented programming. But if you don't want an interface, I would say definitely you can just prepare some scripts and run the scripts. And if that is sufficient for you and that suits your application, I'd say go for it. There's no particular reason to go for object-oriented programming. Yeah. Yeah, any more questions or? Yes, please.
How would something be handled, like if one of your functions would be like calculate so many digits of pi, and the computer is busy for a whole time, the whole interface would be blocked.
Exactly. So we'll have a look at that in the next session. That comes back to this threading thing. So what you would do is you would you prepare a function that does what you want, but instead of executing as in the main thread, so-called, in the main sort of execution window, to call it, to give it a name, you would execute in a separate thread. So you tell the computer to start doing this, but don't stop don't stay busy just on that. Okay, so that's the whole point of threading. It's, as we're going to see it here, it's going to be just a few lines of code that lets you do that. But you also need that because once you imagine you were to start a certain measurement, this would block your interface. Actually, you wouldn't be able to click any buttons until the Python console terminates doing what it's doing. So actually, being able to interact with an experiment while it's running requires threading, and that's what we're going to deal with next time. Okay, so we're going to see a very basic example, and next time also we're going to see a little bit of plotting, so you can see data in real time as you're taking it. And yeah, it's going to be using this particular circuit examples. Yes.
For this Python program in general, for me the problem is there's too many libraries. Like if there was just one, you'd get.
Yeah.
So any suggestions?
My suggestion is to use the ones that you need. I mean, look at.
There's like I don't know, to implement it neatly or whatever. There's different options for to plot.
Yes, definitely. I would say for plotting and for user interfaces, the one that I know of and I use is this pyqt. I find it useful. It does what I need. I haven't gone off looking for more libraries to do better. Maybe there is, probably there is a better way to do the same things that I'm doing right now. This is good enough for me. This is what I'm showing. But yeah, I would say, generally speaking, start with some examples and always start with your experimental needs. Okay, do you need something? Then see what is a way to implement it, and then you might come across better ways to do it. But I would say with the libraries, I mean, all I'm using here is literally what you can see at the top of these scripts. So yes, Anaconda, once you install it, it's a few gigabytes of data. Do I use it all? Absolutely not. I use a few. I use definitely the serial library. I use the Visa library. I use the OS library, NumPy, which is sort of universal for sort of mathematical operations, and really not many more. The pyqt. This one, the pyqt and the pyqtgraph, which we're going to use. But yeah, for example, for plotting, the pyqtgraph, which is what I use, is okay. It works fine. I'm assuming there's better ones because yeah, exactly. Yeah, I could use pyqt5. I could use pyside. Does it matter? Probably not. It doesn't matter. I would say don't stress about, oh, I need to find the best library for what I'm doing. Just find one that works, and once you're comfortable and you have an additional need, then you might go and look for a different one that does it better. I would say don't worry about all the packages. In fact, I haven't mentioned it, but particularly in a company environment, you can't really use Anaconda freely. So that is sort of free up to enterprises for up to 200 employees. But if you have a bigger organization and it's not an academic one, you might have to use a different distribution. And in fact, Anaconda has a version which is called Miniconda. And Miniconda, actually, if you go in the Anaconda web page, you will find a comparison about whether you should use Anaconda or Miniconda and what is the difference. The main difference is that it has fewer packages, so you might need to install more, but it will not bloat your computer with things that you don't need. So you might want to go for Miniconda. It's possible, I don't know, I haven't used Miniconda in a while, but it might be that you have to install, for example, Spider separately, or the pyserial separately, the pyvisa separately. So in the case of Anaconda, some things come pre-installed, and the only things that you need to install are the 3 that I showed in the beginning. If you install Miniconda, it's perfectly fine. It's actually using the same repository, so you'll end up with exactly the same packages, but it's actually free as in it doesn't have any requirements, even if you're running it in a company or something. So yeah. Maybe there's any more questions here. Let's see. Yeah, there's one. Let's see what go there. Right. Thank you, Jose, for asking that. Personally, I have never done that. So Jose is asking if you can create an executable file. I know that you can. You definitely can. How easy it is, I think it's not too difficult, but I never tried. I always run things through the Spider interface. I always run things through the Spider interface because it gives me I'm more comfortable this way because I rarely run the same thing, the same code for a long period of time. Usually I do my experiment, and already after a few experimental runs, I already need to change something in the code. So I'm always fiddling with the code. But if you're running, or if you want to send this as an executable to a collaborator or someone, I'm sure there's definitely easy ways to create executable files. I don't quite know how it works for the compatibility in the libraries that the computer needs to install. So you'll have to look it up. But I'm sure there's lots of resources online. I'm afraid I can't help you with that at the minute.